Right, year 8. Have page 93 out in front of you so that you can mark your homework that was due for your lesson this week. Okay, so let's get going. So here's my question 1 filled in. So the voltage of a cell tells you the size of the push that the cell will give to the charges that flow in the wires. Now in my everyday teaching I would tend to say electrons for that, but electrons wasn't one of our options up here, so that's why I didn't write that there. So the charges flowing produce a current. If the voltage is bigger, more energy will be transferred to the components by the current. And if you had charges in here, that would be all right as well. Okay. Voltage is measured in volts using a voltmeter. So let's look at number 2. So here are some ways of connecting a voltmeter in a circuit. The battery has 2 cells and each cell has a voltage of 3 volts. So that tells us that the voltage of this power supply, because there's 2 cells and each one has a voltage of 3, that means that voltage there is 6 volts. So if I was answering a question like this, I would fill that in as I was reading the question. Okay. So for part A, what is the reading on the voltmeter connected to positions 1 and 2? So if you remember last week, I showed you that this diagram was drawn a little bit strangely. So this is trying to show us that the voltmeter here is plugged in across the power supply. So that's that 6 volts. What's the reading on the voltmeter connected to positions 3 and 4? And again, I showed you that would be as if this is how we would draw it normally. This diagram is drawn very strangely. So the rule for voltage in parallel is that the voltage is the same across parallel branches. So there's only one component in this first parallel branch that we're looking at here. So that means all 6 volts will go to that one bulb. So that's also 6 volts. Then, what's the reading on the voltmeter connected to positions 5 and 6 when the student closes the switch? So that is this one here. And in this parallel branch, there's 2 components. So we know the voltage across the whole branch is going to be 6 volts. We figured that out earlier. But the rule for voltage in series is that voltage splits across components in series. So if you've got your 6 volts, that's going to get split across these 2 bulbs. So each bulb is going to get 3 volts. Okay, so number 3. Write T next to the statements that are true and false to the ones that are false. So for A, a voltmeter is always connected in series with a component. That is false. Voltmeters are connected in parallel. B, a voltmeter is used to measure voltage. True. You measure the voltage through a component and the current across a component. That's false. You would say those the other way round. So you would say you measure the voltage across a component and the current through a component. D, the voltages across 2 components in series will add up to the voltage across the battery. That's true. 2 cells of 1.5 volts each would always add up to give 3 volts. Now this is actually a sneaky one. A lot of you have probably put true for that, and I can see why, because the rule would be if they were attached correctly, they would add up to give you 3 volts, but it's actually false, and I'll show you why. So if I had a cell like this and another one like this, then that would connect to give 3 volts if each cell was 1.5 each. But if they were connected the wrong way round, so if we put the negative and negative together of them, then that one wouldn't connect to give us 3 volts. These 2 would end up cancelling each other out and we would get 0 volts that way. And the same if we'd done it the other way around, if we connected the 2 positives together. So that was a sneaky wee one there. Okay, so I have filled in the extension question here. So what would happen to all of these things when the switch was closed? So here's our switch here. It's in this little parallel branch. And the first one is the brightness of each lamp. So we've got lamp A, lamp B, and lamp C. So C and B were fine whenever the switch was open, so they're going to end up staying the same. So C and B stay the same, but lamp A, because now the current is able to flow and deliver the volts to bulb A or lamp A, then the brightness of A is going to increase. It's going to go from not being on at all to now being on. The reading on voltmeter 1, so because it's connected to bulb A, it's going to increase from saying 0. Whenever the switch was open, there would be no current here, so it can deliver no volts to it. But as soon as this switch is closed, then the volts can be delivered, so it's going to increase. So that's what I mean by that wee arrow, increase. C, the reading on voltmeter 2 and 3 for part D are both going to stay the same. And then the reading on the ammeter is going to increase, because whenever you have parallel branches, it means you end up having to take more current from the power supply. So there's a tricky enough wee question there, that part E. Okay, so hopefully you filled in any corrections if you got any wrong, and obviously marked it. It was a tricky enough wee homework, so hopefully you got on all right.